Hi, welcome to our math. Today I'm doing a series of videos on higher order polynomials. This says find all the zeros of the following polynomial. Don't forget some can be complex, and that's what this 5i is. Just for the record, because of the way complex solutions are, if 5i is a zero, negative 5i is also. They always come in complex conjugates, which are positive and negative pairs. All right, so we're going to do synthetic division to factor these two out, which is kind of trippy. I think doing synthetic division with imaginary zeros is just crazy. So if I take out 5i, my coefficients are 1x to the fourth, 1x cubed, 23x squared, 25x, and negative 50. I need to leave myself room. I always forget to do that when I'm doing this. I'm going to bring down the 1, and then I'm going to multiply 5i. This becomes 1 plus 5i, and now I need to multiply, and I'm actually going to do my multiplication down here. 5i times 1 plus 5i. I don't know if I left enough room for you guys to see the work I'm doing, so I will scooch this over. This becomes 5i plus 25i squared. I do want to note that I is equal to the square root of negative 1, and I squared is equal to negative 1. So this becomes 5i minus 25. When I add down, I get 5i minus 2. Now I'm going to multiply those. So I'm going to multiply 5i times 5i minus 2. These will multiply to be 25i squared minus 10i. 25i squared is minus 25 and then minus 10i. These will cancel and I'll be left with negative 10i. So 5i times negative 10i becomes negative 50i squared, but I squared, of course, is negative 1, so negative 50 times negative 1 is a positive 50. And look, it worked out. It's insane. All right, right. So for my next trick, I'm going to take out the negative 5i. My coefficients are 1 plus 5i, 5i minus 2, negative 10i. And I will tell you right now, this will be a lot cleaner than the last one. You're like, if that's how insane this one was, how? No, it's not. Because when I multiply these, I'm going to get a negative 5i, and I'm going to be left with 1. And when I multiply these, I'm going to get a negative 5i, and I'm going to be left with negative 2. And when I multiply these, I'm going to get a 10i, and I'm going to be left with 0. And how beautiful is that? It's just beautiful. I'm left with, if this is an x to the fourth, this is an x cubed. If you're curious, this is really x cubed plus 1 plus 5i x squared plus 5i minus 2x minus 10i, which is stupid. No, it's not stupid. It's fun. It's ridiculous, right? It's just no one. Yeah. This is x squared plus x minus 2, and I want to factor that, and that is very factorable. Let's see, if I did negative 1 and 2, that would add up to positive 1. So this is x minus 1, x plus 2. And so this is 0 when x is 1. This is 0 when x is a negative 2. And we have our other ones of 5i and negative 5i. So those are our 4 zeros. And that's exactly what this video is trying to find. If I wanted to do a bit of extra credit and write this initial function in terms of its factors, dun, 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 I would have f of x equals x minus 1, x plus 2, x minus 5i, and x plus 5i. That's your extra credit for the day, writing a function in terms of its factors. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you in the next video. Thanks.